Hello everyone again, this is Miss H. Today's topic is radical equations. If you recall, we went over radical equations before and I said that I would do more of them. So I picked today two major problems to do that are a little more difficult, and we're going to discuss them and see if we can figure them out. Okay? All of these equations are from Kudo software, so you're more than welcome to peruse them and practice from Kudo software. All right, take care. All right, here we go. Ladies and gentlemen, as I look at this radical, I see there is a radical. What type of radical is this, you ask? Well, there's nothing in the index, so when there's nothing in the index, we call it a square root. So that's very important. Square means 2, so that's very important for us. Next thing, I see that there's an 8 on one side of the equal sign. That's not going to help us too much sitting there. So we need to do something called isolate the radical. When we say isolate, we mean get it on one side of the equal sign by itself. Try your best to move it so that it's by itself. Sometimes we have two radicals. We have to decide which radical we want by itself on one side. We have to make that decision. And it's easy enough. Usually we look at it and we kind of decide, make a decision. Either one you pick is going to result in the same answer. Here we go. Now let's take a look at this. Seeing that there's an 8 on this side and we need to isolate, let's subtract the 8, take the inverse to both sides. That's the first thing I'm going to do so that I can cancel out the 8 on that side and so that I get my radical by itself. Obtaining that radical by itself is so good because it helps us out so much. Now, here we go. Once you have the radical by yourself, how do we get rid of a radical? Well, we know that from learning math so many years. If we square a square on a radical cancels them out. But remember, whatever you do the same thing that you do on one side of the equal sign to the other side so that it balances the equal sign. It has to be a balanced equation, okay? So, once again, a square cancels out a square root. So, we end up with x plus 1 equaling, negative 6 to the second power. That's negative 6 times negative 6. That's what negative 6 to the second power equals. That's a negative 6 times a negative 6, which is a positive 36. So this is what we have right now. We have a simple equation. Now, how do you solve for x? Once again, the inverse. Here we go. X equals 35. Cancels out. Now, do we know for sure that this is correct? Now, that's the question of the day. How do we prove that this is correct? What we do is we check. And there's a specific word if it doesn't work out. And I'm going to talk about that because I think it's important for us to know, just like the word isolate is important. So I'm going to write my original. I'm going to put x plus 1 equals 2. That's my original right there. Okay? And I'm going to move this up a little so you can see really well. Here we go. So 8 plus radical 35, all right, that's what it is, plus 1 equals 2. Well, let's do the work. 8 plus, what's this? What is the square root of 35 plus 1? 35 plus 1, that's 36. There it is. Equals 2. Well, 8 plus, what's the square root of 36? We know that 6 equals 2. This is 14. Does 14 equal 2? No, it does not. So we know that even though we did the work correctly, we did this work correctly, we did, it doesn't work out. So we call that extraneous, extraneous. That means that you did all of the work correctly, but it doesn't satisfy the equation. So you do obtain an answer, but it doesn't satisfy what we have done with the equation that we were given. Okay? So it's extraneous, but you did all of the work correctly. Okay? Now that's our first problem of the day, and I thought that was a very good one. Now let's do another one. Now, here's where the trouble comes, I think, most of the time when you have equations on both sides. What do? Everybody thinks it takes so long. I don't know why. They think it takes so long. They always say, oh, it takes too long to do it, the students. But it really doesn't. Let's take a look at it. We have two radicals on the same side. I'm asking you to tell me which radical you like better so that we can isolate it. Remember, you have to isolate one radical on one side of the equation. You cannot have these two on the same side. You have to isolate one. Isolate it. It makes it much easier. I'm going to isolate this first one. Now, how am I going to do that? I'm going to take the opposite of the operation that's happening here. They're saying subtract this radical. So watch what I'm going to do. I'm going to add this radical to both sides. Watch what happens. Add the radical to both sides. I'm going to add it. If I add this to a 0, I end up with the same thing that I started with, x plus 12. That's the same thing. 0 doesn't change it. But look what happens here. If you have a minus and a plus, this whole thing will cancel out. I am left now with the radical that I wanted to isolate. You see that? That makes it so much easier. Now we can work very easily. Watch. Remember what we said. A square cancels out a square root. That's what we said. Let's not make this hard. This doesn't need to be hard. Look, a square cancels out a square root. So that by itself is this. There you go. Same thing over here. A square cancels out a square root. That's 3x minus 3. That's easy. So now we have a basic equation, something that we've done many times before, starting from freshman year. So here we go. Minus x, minus x. We're getting rid of these things that are on both sides. We wanted the x's on one side and the whole numbers on the other. So we're doing some moving. That's gone. We're left with 12 on this side. This is 3 minus 1. Don't forget there's a 1 on that x. Don't forget that. So that gives me 2x minus 3. There we go. Now, how do we get the 3 by itself on the other side? Well, it's the inverse once again. It's the inverse. That's what it is. And we end up with 15 equaling 2x, because that's going to cancel. How you doing so far? Now, it's going to give us a lovely fraction. I'm so excited. Okay, here we go. Divide by 2 to both sides. Divide by 2. We end up with x equals 15 over 2. Now, if you want to, you can change that to a mixed number. I don't know if I want to, but if you want to see it, I can do it for you. Or 7 1/2. What did I do? All I did was I took my 2 and I divided it into 15. That's how you simplify fractions or make them into mixed numbers. 2 divided into 15 is 7. 7 times 2 is 14, leaving you with 1. You take the bottom number and put it over the side number, and you get your answer. That's just a little side note. Give you a little review in that, a quick review. Okay, so far so good. Now, I don't know for sure that this is the answer. You know that from before. We always have to check these things, make sure they work. So I'm going to check them. I know you're saying, oh, the fraction, don't like fractions. I know, but this is the problem. This was the answer. I would suggest that you leave it in this form. It would be easier for you in the long run. Here we go. The original equation, here I go. 3x minus 3 minus radical x plus 12 equals 0. That's what it's supposed to equal. We're going to see right now. You ready? I don't know if it works. Let's see. Radical 3 and 15 over 2. Close. That's where I'm substituting minus 3. Minus radical, open parentheses, 15 radical 2. I want you to see where I'm substituting. That's why I put the parentheses. Plus 12 equals 0. Well, let's do the work. How do you multiply a whole number times a fraction? You put a 1 underneath. Remember that idea of putting a 1 underneath? If you put a 1 underneath and multiply across, you can go ahead and do your fraction. That gives me 45 over 2 minus 3. Right? And I'm going to show you something with that. And this gives me, you ready? There's no work here, but let me show you something. Wait a second. If I want to put these two things together or these two things together, I have to do a little bit of work. You do see that. I need a common, they call it a common denominator. Now, what would be the common denominator for this? 2. I would hope that we can change this to 2, but make sure that whatever you do on the bottom of a fraction, you have to do on the top. So you can't just put that in. You have to multiply the bottom and the top by 2. You see? So this is 15 over 2 plus 24 over 2. Because you have to multiply and get that denominator. Here, I'll do it over here also. Put a 1 underneath. I'm going to multiply 2 on the bottom and 2 on the top. So I have a common denominator. Watch. It's 45 over 2 minus 6 over 2. And this one is 15. I'm going to write it over again so we have it together. 15 over 2 plus 24 over 2. Well, let's do the work. What is, now that they are common denominators, I can keep the denominator and do my little radical, you know. What is 45 minus 6? We all know that. That's 39. Oh, that's nice. Okay, so we were able to do the fraction without pain. What about this one? What is 15 plus 24? Oh, wow, look at that. 39 over 2. Now let me ask you a question. What is 39, radical 39 over 2 minus radical 30? If you subtract the same exact thing, you know you're going to end up with this lovely thing called 0. So guess what? This is actually the answer for this problem. Can you imagine that lovely fraction? So I really wanted to do that with you so that you can get a real idea of how to do these, because you always tell me how hard it is to do these ones with the 2 in them. And that's not really that hard, is it? When you think about it, it's not that hard at all. So I hope that helps. And maybe if you want additional ones, we can do some more if you'd like. You just let me know and I'll put some more up for you. Okay? Thank you very much for joining me. Have a wonderful day. Miss Hollingsworth signing off. Take care.